Kia ora, welcome back. I'm the Kiwi Coder, and today I'm here to show you how to make your character aim a weapon at the center of the screen, like you can see here. So the weapon follows along with the character's animation, as you can see. Its axis is actually fixed to the center of the screen, even while moving. The head and the body both also follow the center of the screen, and yeah, the character can turn in circles and everything else. Before we get started, I'm just going to show you what I have in my scene here. So this tutorial actually follows on from two of my previous tutorials. The first one is the third-person shooter character locomotion tutorial, and the second one is the Unity animation rigging attaching a weapon tutorial. You can follow this tutorial first and then this one second, and that will get you into the same state that I'm beginning this tutorial from. So in our scene, we've got the character, which has got the character aiming script, the character locomotion script. It's got a rig builder. It's got some physics, an animator. We've got Cine Machine looking at our character. We've got the weapon added as a child of the clavicle, and some hand IK stuff. Cool. So yeah, we're ready to get started now. So the first thing I actually want to do is change the way this weapon is parented to this clavicle bone. One reason for doing that is this weapon is currently inheriting the position and the rotation from this bone, and I just actually want to inherit the position only. So we can do that just by dragging this out, and we're going to use a new constraint node from the animation rigging package to do this. But just before we do that, there's just something that we want to do to save ourselves some time a little bit later, which is actually change the pivot point of the gun. Currently, when you rotate the gun, it's rotating around the handle, which it's okay, but it actually makes it a little bit hard to aim with. So we want to change the pivot point just to back here. So if you create a new child node here called like weapon pivot, and just move that node somewhere up the back here, and we want this to be the parent node, so we just drag it out and then drag the weapon as a child beneath it. And now when we rotate that parent node, the gun actually rotates around the butt point, which it makes it much easier to aim with. I'm just going to move this slightly forward. Yeah, that looks much better. Cool. So yeah, now we have our weapon pulled outside of our skeleton. We're going to create a new rig layer to handle this parenting to the clavicle bone. But before we do that, I just want to rename this rig layer to hand IK. And cool, because we're going to be creating a few different rig layers, so it's handy to give them different names. So this one is going to be called weapon pose. And we need to attach a rig component to that, and we need to then assign that rig into our rig builder. And the order here is important. The hand IK should always come last. Basically, we want to aim our weapon and then make our hands attach to the grips as a final step. So the order of the rig layers here should match the order of the rig layers in the scene, because that order is how the animation system will process each of our rigs. Cool, so we've created our new weapon pose rig. So let's just create a new child called weapon pose, and this is going to use a multi-parent constraint. So we want to constrain the pivot point of the weapon to this node, and let's just set the offset to none. And what this effectively does is parents this weapon pivot to this pose point here. The pose is currently to the floor, so we just want to swap the transforms of this pose and this pivot. So if I just copy this and paste this into the pose, and then clear out the weapon position, now our weapon pose is up here and our weapon's down here. So if we hit play, yeah, now we have the weapon is it's basically, yeah, this multi-parent constraint node is constraining the weapon to this weapon pose node here. So you can see that if I change the position of this pose node, So notice I'm not changing the position of the weapon, it's of the weapon pose. It correctly updates the weapon position, which is pretty handy. So one thing that you might have noticed is the position is not being inherited from our clavicle bone, because we pulled it out of the skeleton. So we can fix that up by adding a multi-position constraint. This needs to be positioned before the multi-parent constraint. Basically, the last step is positioning the pivot to the weapon pose. So the thing that we're going to constrain here is the actual weapon pose itself. So this is basically saying inherit the position of the clavicle, which we'll select here. Inherit the position of the clavicle into this weapon pose node. If I just turn the offset off, now if we have a look at this, it's going to look a little bit weird. Not too weird, but yeah, the offset's just currently it's constrained exactly, so we need to just adjust the offsets here, so it looks a little better. Cool, yeah, so that's looking pretty good, and you can see that the weapon is now bouncing along with our character, which looks much more realistic. So I'll just copy these values, paste them back into the constraint, paste component values. Cool, so now we have our hand IK, our weapon pose layers set up, and our weapon pivot is all good. So we're ready to actually start aiming our weapon. So I'm going to create a new rig layer. I'm just going to duplicate the weapon pose one that we have here. And I'm going to give that the name weapon aiming. So we need to assign that to the rig builder. Position it in the middle. This is the order that things are going to be processed in. So first we pose the weapon, and then we're going to aim it afterwards, and then we're going to attach our hands to the weapon. So yeah, if we just hit play, not much has changed, but we can actually change this pose here, specific for this weapon aiming rig. So if I just zero out the rotation, that's going to give us a pretty good starting point. It's a little bit far back, so we need to just adjust the position. Oops, not that button. The Z position, and then push it down a little bit, and push it in a little bit that way. Yeah, something like that. Maybe 8. Cool. So yeah, now we have a new pose for our weapon, for the aiming pose, and I'll show you what happens. Basically, we can then blend this rig layer in and out, and see how easy it is to go from the running pose to our aiming pose, which is pretty cool. So this, you can imagine this weight controller being controlled either from script, or you can control it from the animation state graph, which yeah, is pretty flexible. So I'm just going to copy these values, come out of play mode, paste them back in, paste component values. So we zeroed out our rotation. Yeah, cool. So just check everything's working again. Yep, looks good. So the next thing is actually to make our weapon look at that crosshair. So to do that, we need to create a new constraint called the multi-aim constraint, and we're creating that under the weapon aiming rig layer. And this aim constraint again needs to go before the parent constraint, because these constraints here are adjusting the weapon pose, which is then used as the source object of the final constraint. They need to come beforehand, otherwise there's going to be syncing problems later on. So the multi-aim constraint needs an object to constrain. So in that case, it's going to be our weapon pose. And the source object is what we're aiming at. So the easiest way to have something to aim at is just create a child object of the camera called aim look at, and just position that 20 units or something in front of the camera, and assign that look at node to the multi-aim constraint. The last thing we need to do here is the aim axis. So the way to figure that out is just to be in local space and use the transform gizmo to see which axis is pointing forwards. So in that case it's the blue one, which is the z-axis. So we just set the z-axis here, and the settings, we need to just turn off the rotation offset because we want our weapon pose to aim exactly at our look at node. Cool, so let's just test all of that. Hopefully it works. Cool. Yeah, so if I look up, the weapon goes up. If I look down, the weapon goes down. And the arms are all following after the fact, which is, yeah, it's looking pretty good so far. So the next thing is actually to adjust the head and the body to make it look a little bit more natural. Currently the weapon itself is aiming, but the head and the body should really follow as well somewhat. I think it just gives a lot more realism to it. So to do that, we need to create yet another rig layer, and I'm just going to call this one rig layer body aim. And this is going to be the very first thing to calculate, so it needs to be at the top. So if we just add a rig component, assign the body aim layer, position that at the top. The reason for doing that is because the weapon pose and the weapon aiming both want to inherit the positions that we change of the body here. So it needs to be the first thing. Cool, so if we just go and have a look at the skeleton for a second, we can see that there's a few bones that we can actually change on the body to aim. One of them is the spine bone, and there is also the spine 2. The spine 3, I think, is not super realistic for this rotation. I don't think people really bend around that joint. It's more used for aiming in this direction. Yeah, and the final ones are the neck and the head. You can actually pick either of these. I'm not 100% sure which looks better, but for this tutorial I'm just going to use the head. And the other two I'm going to use are the spine and the spine 2. Cool, so we're going to create a new node called, let's just start with the head, aim head, and use the multi-aim constraint again. So just drag the head node in there. Again, to figure out which axis it is, we just select the head, use the transform gizmo, make sure we're in local space, and it's the blue arrow pointing forward, which is our z-axis. So we just change the z aim axis here to z, and then the source object is the thing that we're aiming at. So just drag in the aim look at node and turn off the aim offset again, just because, yeah, we want it to aim exactly. Cool, so yeah, let's just test this out. If I look up, the head now looks up. If I look down, the head looks down. It's already looking way better. So let me just quickly do the other two nodes. So the first one is called spine 1. Second one is called, spine 2. And then we want to assign spine 1 and spine 2. And the order of these constraints is again important. So you should really process the sort of the root nodes first and process the leaves at last. So we want to move our head down and our spine is at the top, yeah. The axis we need to just double check. So if we look at spine 1, the forward axis is negative green, which is the y-axis, so negative y. And for the spine 2, it is positive y. So spine 1 should be negative y, spine 2 should be positive y. Just make sure the rotation offset is turned off, and let's check that out. Woo! Sweet. Looks well good. It's probably a little bit too exaggerated, so it's really easy to turn this stuff down. you can just use the weight knob things here. So if I just set that to like something smaller, 0.2, yeah, it looks a little bit better. It's not so drastic. Yeah, so yeah, I mean, this is looking pretty finished, really. There's just one final thing to check. We just want to verify that all of this stuff is actually working. I mean, it looks good, but we don't know. We haven't really verified that the aim axis is actually pointing directly at the center of the screen. So I need to just paste these values back in. So the final way to check this, I find, is just visualizing the aim look at node and the aim axis. So to do that, we can just create a 3D sphere and add that as a child of the look at node, reset the position, and it should be somewhere around here. It's over there. Let's just set the size, maybe like 0.3, just so it's a bit smaller. Cool. And the other thing that we need to do, let me just show you that first. Cool. So in the scene, maybe it's a little bit hard to see, but yeah, you can see the sphere on the crosshair there. So that's actually, yeah, the thing that we're looking at, the node that we're looking at in our constraints. So let's just do basically the same for the look at axis. So I'm going to do that using a cube, and I'm going to attach the cube to the weapon. And oops, let's just reset the position, set the scale to something small, and then you just want to like position it so it's kind of, let me just pull this up a minute. Position the cube so it's like coming out of the barrel of the weapon. About there is good. Maybe just make this a bit smaller. Oops. About there, up a little bit. Something like that. That's pretty good. And we'll just make this now super long. It's basically like a laser sight coming out of the weapon. Cool. Yeah, so we'll use that axis to check that it overlaps with our look at node. And I'll just reset the position on the weapon here. So if we hit play, oops, oh crap. Yeah, sorry, when I added the sphere, it actually creates colliders, which we need to turn off. So if we just remove them from the sphere and the cube, check play mode, yeah, cool. So yeah, we can see our laser is passing through the center of the object pretty accurately. The only thing is this delay, this like lag and jitter you can see, which is actually not great, and it's going to be, just makes your weapon not very accurate when you're doing raycasts and that sort of thing. So to fix that, it's an update order problem. I've actually made this little diagram thing here. Let me show you. Yeah, so currently the animator is being updated inside fixed update, and when the animator updates, it's updating our root locomotion, the forward, backwards, left, right keys, and the animation rig, which is all the IK stuff that we've set up. So basically the weapon is aiming at that aim look at node we set up. And then what happens in late update is Cinemachine updates. Processes the mouse move and changes the camera position, which in turn changes the look at node. So by the time it comes to rendering, our look at node is now ahead of where our IK is. So we basically need to move Cinemachine before the animator update. Like that. Amazing transition. Yeah, so this was the only way I could figure out how to actually do this. It's not super flexible about changing update orders from what I can see in Unity, but Cinemachine has got a thing called blend update method, and it's currently set to late update. So if we change that to fixed update, and then actually I can do this at runtime to show you what it looks like. So if we set that back to late update, yeah, so we can see the jitter here. Let me make the screen bigger. We can see like the jitter here, and if we go to Cinemachine and change the blend update to fixed update, yeah, it's now way better. The Did I even? Oh, yeah. You may have your update method set to animate physics, which is still incorrect because even though now Cinemachine and the animation are both updated during the physics step, and it's a bit confusing about which one will update first. So to fix that, I just forced the animator to update during the normal update, and Cinemachine updates during fixed update. So the final thing that we need to do is actually just write some tiny amount of code to adjust this this aiming layer in and out as we press like our right mouse button, for example. So if we just go to our character aiming script, yeah, this is actually the first time we're opening the code editor, which is cool. So we need to get a reference to our rig, and that can be found in the Unity engine .animations.rigging. That's the new animation rigging package namespace, and it's called rig. So let's call this like aim layer, something like that, and then just do this in update. There's no point processing input and fixed update. It's just doing more work than you need to, really. So inside update, we can get the basically just check if the mouse button is down. Mouse button. So I'm going to use the right mouse button. So if the mouse button is down, so we actually need to create a new variable called aim duration. Let's just give this a value of like 0.3, I guess. And this is going to control how long it takes us to aim after pressing the right mouse button. So we can update the weight of the rig layer using that variable. So just plus equals time dot delta time divided by aim duration. Otherwise, we can just subtract that weight amount. So we just divide by the aim duration here just to normalize it into a 0 to 1 range. So if we just build that, go back to Unity, yeah, hit play. It's crashed. I think I forgot to assign a reference somewhere. Yeah. So the character aiming. Yeah, actually I didn't. I need to make this public and actually assign it. So if we go to the character aiming scripts, we can now assign the weapon aiming layer. And fingers crossed this all works. Cool. Nice. Let's see what that looks like from here. Yeah, it's not too bad. It's pretty good. I would probably just increase this duration, make it a little bit faster, like 1.8 or something. Yeah, something like that. It's pretty cool. That's it for this tutorial, guys. If you made it to the end, really appreciate you watching. Hopefully you followed along with some of your own assets and everything went smoothly for you. If it didn't, just leave a comment in the comment section below. I'll try to help you out where I can. And yeah, I'm going to be releasing a ton more of these videos around the animation rigging package, procedural animation. Just this whole space is pretty interesting to me right now. So if you'd like to see more of those videos, just hit the subscribe button, check that bell notification icon, and hit the like button. And yeah, we'll see you again. Ka kite!